Good morning, everyone. So welcome back to our third week of Medical AI. So great to see some new faces here as well. So what we're going to be spending the next 2 days on is what's happening right now in AI, right? And so some of this stuff honestly is like, you know, like last week, like a few weeks ago, that sort of thing. So a lot of this stuff is very, very new, right? And part of the reason is because AI is such a fast moving field, right? Like to keep track of what's happening, that sort of thing. It takes quite a lot of effort. But in order to sort of put in like interesting work or actually do interesting work, right, you need to be able to keep up to date with what's happening. And there's always sort of stuff happening. And so hopefully this also provides you a bit of a background so that if you see something, right, you also understand what is actually, what is actually happening, what that actually means, right? And so, something like this as well, like if we present it now, probably in 6 months, it's going to be sort of obsolete. And so just again, providing you a basis to how to think about some of the stuff here. Hopefully you spent a lot of time last week understanding transformers, and hopefully you understand it a lot better now. We always still have lots of questions about how transformers work, so don't stress too much if you don't fully understand how transformers work. It's rather just, do you understand the intuition behind transformers? Do you understand sort of the key concepts of how transformers work? And at its heart, it's a really simple concept that has led us to all the stuff and all the sort of exciting stuff that has happened recently. But also asking what's next, right? As I showed sort of at the start of the course, GPT-5 is doing more poorly than we expected, which means that we sort of need something new soon, right? And last time it took us like 7 years for someone to figure out something new, right? And so hopefully this time it's a lot faster, and that next breakthrough happens a lot faster, right? And then the sort of AI wheel starts to spin again. So
Great.
Today we're going to be covering state-of-the-art stuff, and so there's a lot of topics, right? And so it's a bit of a whirlwind tour, right? And not all of them are related, not all of them build on top of each other, like we have been trying to do recently with Transformers, right? A lot of it's just like, whoop, we're just going to switch to something new now, and then sort of discuss this. And so all of these terms might seem really, foreign to you, like it's unclear what some of them might mean, right? But I promise we'll go through like each of them slowly and sort of discuss them. Now, sort of disclaimers. So the goals of this session is to bring you to the edge of knowledge so you can do interesting stuff, particularly for your project, right? Which is the next 2 weeks after this week. And we'll actually start some thinking on what the project would look like later this week, right? And actually get you to read some papers and discuss with people here as to what might be interesting. And the disclaimer is, most of this stuff is quite new, and so there's actually a lot more questions than answers. So some of these are active research topics right now. We literally don't have an answer, and someone just needs to do it, right? Like someone like yourself needs to figure it out. So it's very exciting stuff. Okay, so just sort of recap before we get started on the new material. So recall that last week, we talked about transformers, and hopefully you dive into each of these with a lot of detail. And so this looks sort of like revision. So in step one, what we basically do with transformers is we pre-process the data. So transformers can't see words, they can't see images or that sort of thing. What they see are tokens. And so for language, what we use is a method called byte pair encoding in order to tokenize the words that we have. Right? When it comes to images, videos, we actually or audio, that sort of thing, we actually have completely different techniques, because as you imagine, byte pair encoding doesn't really work for that. Or maybe it does, we don't know actually. No one's actually tried byte pair encoding for images and videos. That might be a really interesting project as well. But yeah, so with byte pair encoding, what you're doing is you're finding the most common letters that appear next to each other, and you predefine how big your vocabulary is, right? And then in doing so, you basically end up with these almost like sub-word type things. And so like common words will often appear together, and so that usually will pop up in the vocabulary. But things like, the eighth, like TH will usually appear together, right, as a subword, and so that's usually seen as a token. And it sort of almost makes sense, right, in terms of like you always have these prefixes and these postfixes that often appear as tokens, okay? So that's step one. Step two is then we do a process called pre-training. So this is self-supervised learning, whereby you basically feed a model unlimited data, and then that model learns information from that data, okay? And there's two methods that we currently use. One is for BERT and one is for GPT architectures, right? So with BERT, we use masked language modeling So for example, it's like IMA, you mask the word and then the model has to guess what that word is. Okay, so that's called masked language modeling. And then causal language modeling is you give it like a phrase and then it has to complete the end of the sentence. Okay, and so that's how GPT architectures work. So there was almost a big struggle between BERT architectures and GPT architectures around 2019, but it seems to be that GPT for now has won just because it's a lot easier to train. And so you're going to see a lot more causal language modeling than masked language modeling. But that being said, people have been trying to see if they can get BERT working because it is a much more generalized sort of thing to have, right? And maybe with more compute, we might have sort of stronger BERT systems than GPT systems, right? But right now, we've got GPT systems working quite well. And so there's a lot of research on GPT systems. All right, step 3 is fine tuning. So once we have this model, yeah, Peter.
Sorry, Brian, just wondering, are there some applications though that BERT remains better for?
Yeah, so generally the problem is with BERT, they always do better on benchmarks, right? So for example, they'll do better on close exercises, or exercises where you're trying to guess, for example, like maybe a biological thing where there's no inherent order, right, in the sentence, right? So for example, like, DNA, I don't think there's an inherent order, right? Like how a sentence is like the start of a sentence, the end of a sentence. With DNA, for example, the start and end are a little bit more meaningless, right? And so it'll do really well to predict like the middle of a DNA sequence, right? But this might not make as much sense, right? So usually it's for tasks where there's no inherent order in what you're trying to predict. But that being said, BERTs are really challenging to train. They just require a lot of compute. They're sometimes a bit fragile to train. And so people still prefer GPT, or they'll try and force it into something GPT. So for example, a strategy I've seen is like, I think it's like genes which are connected, so they use a graph-based method in order to have order for the DNA, right? Rather than predicting just a whole DNA string, because order is a bit meaningless. So you sort of need to have inherent order to use causal language modeling. Okay, great question though. Any other questions? Okay, so that's pre-training. So as you can imagine, if you upload the entire internet and you get the AI model to predict every single sentence written on the internet, you get a very powerful model, right? Like a model that can guess what the next word is, okay? And that's the whole magic behind GPT systems right now, which is you ask it a question, it starts a sentence in some way, and then it guesses what should come next, okay? So that's pre-training. Step 3 is fine-tuning. So after you sort of build a model that is just pre-trained, it's not very useful, right? So if you ask it for output, it sort of outputs generally stuff it learns from the internet. Like, I think I called it Internet Dreams, if you recall from a few weeks ago now. It just spits out like a random Amazon review or a random comments on Reddit or whatever it is, right? Like just a random meaningless thing. And so it's not very useful. But then what you can actually do is something called instruction tuning, which is you actually train it on a bunch of Q&As that are human written, okay? So it's like, hey, this is a question I want to ask you. This is an answer that I expect, okay? So human written, usually around 100,000 of these. Once you fine tune it, then the model for some reason uses the knowledge it's gained from pre-training to answer your questions, okay? So that's called an assistant model. So it uses all the knowledge of the internet or the world or whatever, and then it learns to answer questions, okay? And this is not, super specific. Like you could almost teach it just how to answer questions more generally, and then it does quite well for topics that it hasn't been specifically trained for. Does that make sense? So you're training it to do something useful, like a function, rather than it's like, hey, you have to have medical questions in here or something, right? So you could, for example, not have medical questions at all in this step, but it still learns how to use the knowledge it's gained in order to answer medical questions. Okay, any questions about this step in particular? Because I think actually there's a lot of untapped potential in this step, right? And we'll discuss this later today. Because if you think about it, step 2 is you build this model with the world's knowledge, right? What else could you get this model to do, right? Does it always have to be like a Q&A type thing? Or is it, like an assistant model? Like maybe we're thinking of, models in a very archaic way, like maybe there's better uses for the model in this step here, right? So that's a very big question. Okay, any thoughts on that? Okay, so that's step 3. Step 4 is something called alignment. It's just a little bit of fine tuning on the edges or sort of fixing it up on the edges. And so this is where If you've used ChatGPT enough, you see these two options and they're like, hey, what do you prefer, right? And so this is technically aligning to human preferences, okay? So that's called preference alignment, right? And we'll go through the techniques, but there are two main techniques right now: is reinforcement learning from human feedback or direct preference optimization, okay? So that's what those stand for. Go through what those mean. Alignment is a very interesting sort of field, and we actually have a whole section dedicated to it. There's the simple stuff, which is like, hey, doctors prefer this answer rather than this answer. Like, it's more detailed in this one, it's less detailed, or whatever. Or you could, for example, tell it to give references. So maybe I prefer references, so give references. But then it also falls into larger questions about how do we actually align AI systems in general with human preferences, right? Because if, for example, you ask the AI to do a really complex goal, how do you know that it's succeeded? It's a very, very challenging question, right? So if you're interested, for example, in existential risk questions, right? Like, is AI going to destroy humanity, that sort of thing? Like, alignment is your research field, right? And a lot of people are really interested in that field as well. Okay, step 5 is to actually run the model, okay? So that's actually it. So the model itself is quite simple. Each of these, obviously, there's maths, related and lots of research into each step. But put together as a whole, it's quite simple what we're doing so far. It's not supposed to be complicated, right? And I think I joked at the start of the course that as AI gets more powerful, it gets easier and easier for AI, people like me to actually teach it, right? Because it's actually quite simple what we're doing. There's no like tricks or anything that we're doing, right? Okay, so that's transformers. Any questions before we move on? Hopefully that's just sort of revision at this stage. Questions? Okay. All right, now just before we move on, a sort of important concept to be aware of is that next word prediction, which is also known as auto regression, right, which is what GPTs do, seems really simple, but is something that seems to be really complex, right? And I don't think as a field we fully understand how complex it is, right? Because if you think about it, in order to predict the next word in a complex sentence, right, you do need to understand quite a lot about the world. You need to have an accurate world model, right? And so, I just put in this random condition that I saw, right? What is Holt-Oram syndrome? If you think about like a medical student, you need like 5 years of training, potentially even more, to understand what this syndrome is, right? And if you think about it, it's like, you need to understand what skeletal abnormalities means, or what, the different names are, or what an autosomal dominant, like what that actually even means, right? So you need to sort of have a rough understanding of what those mean in order to describe the syndrome, right? Which is why you spend 2 years like studying just even the basics before moving on to conditions, right? And so if you think about it, this AI has at least some understanding of these concepts in order to actually spit out that sentence, right? Is it true understanding? I don't know, right? But it seems to have at least some understanding of the world, of the world itself, and what these different words and concepts mean in order to string together a coherent sentence, right? And so intuitively, like a lot of people have compared it actually to the evolutionary loss function, which is survival, right? Even just such a basic optimization has led to quite a lot of complexity in this world, right? Which is like all the stuff we're seeing now. And so just that sort of basic autoregression seems to be something very, very powerful, at least for language models, okay? Is that going to be the one that's dominant in future? I don't know, but it's one that sort of people have found to work quite well right now, okay? Any questions about that point? Okay. So, what we're going to talk about first is how to use transformers practically. Okay, so I'm going to get you to do some code again this morning. The code is actually mostly in this section, and I think maybe, I think it's just this section actually. The rest is a lot of discussions and actually playing around with different tools. Okay, so we're sort of getting a little bit more code light as we're getting to the end of this, right? Just because some of this, as you might imagine, can be quite complex from a code perspective, right? There's people who spend like 6 months or 12 months just building something, and will play around with some of their tools. And at this point here, like particularly for some of this complex stuff here, you can really code using AI. That's going to take some time though, right? And so we don't expect you to code this stuff from scratch, right? It's rather that just you have an idea of what tools you might be able to string together and use, okay? So, practical stuff about transformers or large language models. So when dealing with large language models, there are 2 broad choices. The first is you can use a commercial API, right? So that is you actually connect directly into the systems of OpenAI or Anthropic, for example, right? So with these, it's actually just some code, and then you have to set up an account and pay, obviously. You know, usually these models are what's called the frontier models, so models which are at the frontier of how AI is going. Okay. Unfortunately, they are not very modifiable. So obviously, ChatGPT or OpenAI doesn't release their model in full, right? You only can access it via what's called an API. So what does an API even mean? It stands for Application Programming Interface. Basically, it's just a way for coders or code to access the software. Okay, so say for example, in your Colab, you want to access Google, then you have to do so through an API. Okay, if you want to access, I don't know, like ChatGPT or medical records or whatever, it's through an API. So you always have to look at what's called the API. It's just a set of documents that state how you can access a software through code. So again, these are not modifiable. So you really, like, it's obviously restricting what you can do, right? And that's sort of the rough costs. So 15 cents per 1 million input tokens. So recall that tokens is maybe like, you know, a single word is around zero, I think it's like 1.5 tokens or 1.2 tokens, right? So that's roughly how much you can input, and then that's how much it costs. So quite cheap, right? You can put in 1 million, you know, almost 1 million words, or slightly more than 1 million, or slightly less than 1 million words, and that would be 15 cents, right? So cheap. And then output is around 60 cents, okay? So if it spits out like, you know, slightly less than 1 million words, like 800,000 words, that's 60 cents. Okay, so relatively cheap, if you can think about that, right? Now, open source is the other option, right? So instead of using like a commercial provider, you can also download what's called Llama free, right? Or 3.2 at this stage. And what basically Meta, which is Facebook, Mark Zuckerberg has done, right, is they've decided that they want to release open source versions of the models that ChatGPT and Anthropic are using, right? And so it obviously is not as good because it's completely free, right? But they've actually sunk like billions of dollars into training this. Now this requires some setup, right? It's modifiable, right? So because it's completely open source, you can do whatever you want to the model, right? And it is actually free. So obviously it's, you know, there's no cost associated to it. So if, for example, you work with a hospital or anything like that, oftentimes people will be like, hey, can you use Llama? Because it's free, right? And it's open source. And so they're not worried about having to pay ChatGPT constantly into the future, right? Yeah.
Does it make it more secure as well? Like just
yes, because you know what you're seeing, right? Yeah. And you know, for example, if you shut off, you know, if you run on your own servers, it's not like it's secretly because you can check the code, right? Yeah.
Yeah, but in terms of like yeah, you can use it for free, but if you want to actually like fine tune that model, right?
You can, yeah.
Surely that would be more computationally expensive than like using like OpenAI, right? If you're gonna actually do like proper fine tuning.
If you want to fine tune?
Yeah.
You can fine tune ChatGPT as well, costs more than fine tuning Llama.
Oh, okay.
Yeah.
Right.
Yeah.
If you're worrying about like patient data, do you have to be careful about using APIs?
Yes, a little bit. So, yeah, so this is a great question. So ChatGPT, whatever you put in, they're going to use as training data, right? So it's really it's quite bad actually. Anthropic says that they don't use it. So consider that how you will, right? And then generally, like if it's, for example, you want to use a commercial thing, I think Anthropic would be the safer bet. And they're also large enough that they have Australian servers, so maybe you can request, right? Because I think with patient data, usually hospitals aren't comfortable offshoring the data, like they just want it in an Australian server at some point, right? But the safest bet again is Llama free on a local server, right? Like that way you can guarantee that no data is coming out. Yeah.
Like, how can you fine tune ChatGPT? Sorry, if you don't have.
They have a function that they have an API like function that allows you to fine tune.
Oh, okay.
Yeah.
Because I thought like you don't actually have access to the model.
Yes. You don't have access to the model, but they give you enough access so that you can fine tune it. Yeah.
So what does the modifiable mean in like the open source one? Is that you can change like the weight or
You can do whatever you want with it. It's just, or the weight, you can change the weights if you like. There's it's a really funny license. I don't recall if I had a slide here, but it's like if you use Llama, you have to, whatever product you release has to have the word Llama in it, right? So, so it's like, but you know, like for patient's sake, it's like Red Llama or whatever, right? Like, but right? And then you know, like what the tricks people have gone around to, you know, to sort of solve this is they change the weights just ever so slightly. It's just like 0.01, like on every single weight, right? And it does roughly the same anyway, right? And so because of that, like they don't have to call it Llama. So there's all sorts of tricks, right? And so yes, you can change your weights, and people have been doing it to avoid the Llama thing, right? Yeah. Other questions, yeah.
So coming back to that point about the data security. So
special. I think what they mean would be probably an Australian server, like a cloud, like server that's in Australia, right? Is that what you mean, right?
Yeah.
I suspect that's what that means. Yeah.
Right, and also with the Apple, they say, they say it's secure even though you're going to be uploading stuff into the cloud. They say it's secure because no one else can get access to it.
Yes, as in, yeah, like it's a secure server, so there's like security measures on the server itself, right? So for example, it's encrypted, right? Like, or it's passwords, like it's password activated or something, right? Or two-factor authentication or whatever. So I think it just means that it's on the server and it's encrypted in some way, and so therefore you need some sort of way to access it in a safe manner, right? Whether it's like password or some other means. Usually that's what that means. But that being said, we have a speaker actually next week on cybersecurity. So if you have questions for LLM cybersecurity in particular, she'll be the person to ask, right? Like she's very knowledgeable about it. Yeah. Cool. Other questions? Okay. So open source is cheaper, as you imagine, because it's free, right? All you need to pay for is the hardware costs when you're running the model, that sort of thing. There's compute, right? And so it's about 40 to 50 times cheaper, right? So honestly, the vast majority of people I think use Llama free, unless they really need the frontier, like the really state-of-the-art stuff, then they'll use ChatGPT. Okay. All right. Now another tool that you need to be aware of is called Hugging Face, right? Very funny tool. Hugging Face. That's the logo. It's a very cute logo. Widely used in the LLM community, it's an open source library for models and data sets. So if, for example, someone has trained their own model and they want to open source it, then you can actually find those models all on Hugging Face, right? Like everyone just uploads it on that. You can find, like, for example, like medical specific models or radiology models, like all sorts of stuff on there, right? It's also an open source library for data sets. So that's where everyone posts their data sets these days, right? So you can find a lot of medical stuff there as well if you'd like. And they also have lots of different tools. And is the next slide, is it? No, it's not the next slide. Later on, I have a list of the different tools that they have, right? And so all sorts of stuff you can do. Okay, so part one. So part one, we're actually going to play with ChatGPT Playground. Now, this one here, you have to create an account and you have to put in some money. So just a few dollars or whatever should be fine. So before we sort of move on to Playground, though, you've probably already seen this user interface, right? Have any of you actually seen these different models? Yeah? Maybe some nods, maybe some not. So if you pay for ChatGPT, then you get access to the different types of models, right? And I think even if you don't pay, you get access to some of them, right? But probably not all of them, right? But if you pay for it, there's actually lots of different models, and we sort of talk about this later, in that because AI is such a new technology, we still haven't figured out how best to use it, how best to interface it with humans, right? So obviously, the one we all know is this, what's called an assistant or chat model, right? Which is you ask it a question and then it provides an answer, right? But that being said, there's like all sorts of cool things. Has anyone ever used GPT with Canvas before? Yes, maybe? It's pretty cool. So Canvas it actually opens up a whole canvas on this side of things, right? Like, and so you could, for example, put in a Word document that you've written or some code that you've written, right? And then you can highlight certain things and be like, hey, can you fix this part in particular, right? Or can you fix these set of lines in particular? Or I don't like how this paragraph is written, can you rewrite this, right? Which is a sort of really cool way. Or, it could be like you're writing code and it's like there's a bug in this section of code, can you double check this section of code, right? And so we'll again talk about later the user interface, but again, we haven't figured out how to use these AI models, how to interface them with humans, right? And so this is, I think, a very active question that is still, very much going to be answered in the next few years, right? How best should we interface with these models, okay? And maybe, for example, it's a voice system, right? Has anyone used like ChatGPT voice before? Right, yeah? So you can, for example, talk to ChatGPT, right? And I've heard of students using it for like OSCE prep, right? Like just pretend to be a patient with this, right? And then how would I interview them? So still lots of sort of things, and again we'll get you thinking about what that could look like in future. Yeah, so this is Canvas. Okay, voice. So let's go to this website here, platform.openai.com/playground. So it's going to require you to log in.
Yep, API credits.
Okay, and then you need to put in API credits. So I think a few dollars is fine. Like just you can try like $2 or $3 or whatever you like.
Hmm?
How do I know if I have API credits?
Oh, what? Do you have them already? I had this thing here which is like pay for API.
No, I might already have credits.
Okay. Yeah.
I think so. I think they're doing both. You know, like they're trying to get as much market share, and then later they'll. If they do, it's straight on. Okay, so just to sort of orient yourself, right? So this is the playground. And what we have here is actually another chat interface, right? So very similar to, you know, what you have just with a normal ChatGPT if you pay for it, or if you use it. And so what we have on the right here actually is you can change the different models that you use, right? And so we'll talk about O1 models, so reasoning models tomorrow. But these are models that are really good at reasoning step by step. Okay, so sort of really cool to play with. GPT-4o is the standard one. 4o mini is really fast if you've ever used it before. So it just spits out obviously lower quality, but we'll talk about it later what it means, but it's what's called a distilled model, which is a model that's been trained on the outputs of a larger model, but forced to be smaller. Right, so that's called a distilled model. This is sort of all the rage right now. Like Gemini's released a super distilled model that can run on your phone, right? Like really, really fast. Really, so it's audio preview. So this is so 4o just means that the model itself can actually run on different types of modalities. So it can accept text, audio, images, you know, so it can output that as well. So it has that capability. Take a look here. It actually also has older versions of GPT-4, and part of the reason is because if you're building a software, sometimes you need it to reliably output something, right? And so, you know, it has the old version so that, you know, companies which are currently relying on the May version, for example, might still need that May version, but they will regularly what's called deprecate that model, which is get rid of it, right? Like just basically stop supporting it. And so just something to keep in mind as you're building stuff. GPT-4 is the model that is most, it's still text-based, so very text-heavy, very fast, very cheap. 3.5 is the old one. Yeah, so that's the different models that are there. You can also, and we'll talk about this later, you can also force it to respond in a certain way. So a classic way to sort of keep information in text is called JSON. So you can look into it. It's just like a format that is structured, right? So it's like, hey, like this is the patient's name, this is the patient's age. So for example, in healthcare, we use JSONs for medical records, right? Because it's like a structured way to have like, it's always the patient's name, then the patient's age, and the patient's allergies or whatever, right? So you can also force ChatGPT to actually output in a JSON format. So that is actually particularly useful for healthcare. Functions, again, we'll talk about this later. With functions, basically what it is you can describe a function to ChatGPT. So in that API docs, you've been looking at PyTorch, that sort of thing, you can copy that in, and then ChatGPT actually outputs the arguments that you should have, depending on what you actually want to achieve, okay? And it's sort of a bit of a precursor so that ChatGPT can learn how to use functions, right? So again, something very powerful and control sort of other software. Now, have you heard of temperature before? Did we cover temperature last week? Yes, okay. So you can actually control temperature, okay? You can control things like max tokens, what the stop sequence is. So as soon as ChatGPT says the word stop, for example, then it stops entirely. Or the word carrot, then it will stop entirely, right? So that's a stop sequence. And then you also learn about top B frequency penalty and presence penalty in the following exercise. So again, this is just a chat interface, right? And it allows you to do all sorts of other things, which is, you know, you can tell ChatGPT what it is, right? So you can say, hey, you're not just a helpful assistant, but you're actually a doctor's assistant or whatever you want, right? Like you can sort of modify its behavior. So it's kind of cool. All right, so this is the chat. And you can play around again, like with these different things here. I actually don't even know what happens if I, you know, what happens with this. This is just the code for the chat by the looks of it. I don't know what compare. Compare means you can get two ChatGPTs and see how it's responding, right? History is probably your history. Okay, cool. And then you can clear stuff. Okay, so that's the chat interface. This is the real-time interface. So this is actually talking to ChatGPT. So again, you got to play with it in the next exercise. So what does it feel like to actually talk to ChatGPT? This is called real time, meaning that you can actually interrupt ChatGPT while it's explaining something to you and then like ask it to do something else, right? So it has that interrupt feature, okay? And that is quite actually challenging from an engineering perspective because you need to sort of almost recognize when the person's talking to you again, right? Because ChatGPT will sort of go off and explain stuff, but just think about it as almost as a human, it's like you're explaining something, someone interrupts you and then brings you in a different direction, right? So it's a little bit more challenging to do. So it's real time. Assistance, so let's take a look at assistance. I actually can't recall assistance. I think assistance is, like different ChatGPT models with different personalities, right? So you could be like, hey, you can be more supportive or you can be less supportive or whatever you want, right? That's assistance. Text-to-speech, we won't play as much with this. You can try playing with it if you'd like, but basically it's like, you know, it's generating voices, right? And so OpenAI has this API called Whisper, which is really good in that you can provide a text and then it will generate speech for you, okay? Like very natural sounding speech. And then completions is, I think, a very old thing. Yeah, they're considered legacy now, so I wouldn't be too concerned about it. But it's like you ask it to do something and then it'll try and complete. It's just like an old legacy thing. Okay, so in terms of exercises, just go to this link here, and then the collab will run you through some exercises to do on the playground. You're probably already on it. It's fine. It's just a short interlude before the next one anyway. But just to sort of demonstrate, so you played around with Playground, but Anthropic has something called Console, right? And just to sort of show like AI companies do think in completely different ways, right? And so we're sort of still at the stage where people are experimenting with lots of different things. And so for example, Anthropic, and I won't get you to pay for this one, but just take a look at it. It actually allows sort of different functionalities, right? And so ChatGPT doesn't have all the functionality either. So system prompt is very similar to guiding the AI to act in a certain way. So very similar to what OpenAI had. They have an explicit thing for tools, right? And so you can actually add, you know, different tools, and these are different functions that Claude actually learns how to use, for example, right? So again, very similar to functions. But then you can also lean into what's called prompt engineering, which is designing the prompt to be in a way that optimizes for how the AI works, right? And so you can actually, for example, like write a prompt and actually improve the prompt, right? So ask Claude to improve what you've already written, right? So that's also another really cool feature that Claude has. See what other stuff they have. They have some sort of evaluation stuff here, which might be useful. Let's see, improve an existing prompt. This is another feature just to be aware of, particularly if you're doing large batch stuff, but you can actually send a giant batch to ChatGPT or Claude, and then they do it for half price for you. So it's just like if you don't need it urgently or in real time, right, you can actually do that. Yeah, so for example, they don't have the voice stuff as much, right? So different companies have almost different souls a little bit in this space, so it's just something to be aware of. In the sort of long run, actually, for coding, that sort of thing, most people actually rely on Anthropic Claude because it seems to do better for coding and more complex questions. And so just something to keep in mind. Right, let's see. So next section, you probably already started ChatGPT API, right? Hopefully, have you managed to set this up, the API keys? Have you figured out how to do that? So just before you sort of move on to the next one, if you go to, let me just open it up here. If you go to this settings here, you can actually create what's called an API key. So API keys is just basically a really long string of letters and numbers that is like a password. So when you're using Colab and you want to use like ChatGPT, for example, you have to generate a secret key first, and then you have to use that key in your Colab, right? For your Colab to connect to your account. Does that make sense? So that's how ChatGPT knows that you're the one using this, and therefore you're the one paying for it. And so just to sort of show you how to safely do this, so if you go to this page here, so you just click on the settings here and then API keys, and then press create new secret key. You can call it whatever you want. You can call it like your name or test or whatever. So create a new key and then copy it, right? So make sure you copy it. And then in this here, to set it up, what you actually need to do is you need to click on this secrets key here, right? And then you need to put in like OpenAI underscore API underscore key as the name. And then you need to copy it into the value. There, right? So that's how Colab allows you to store these secrets, okay? Now you might see code where the API key is actually out in the open. That's usually considered bad practice because if anyone steals that password, they can charge your account, right? Like, so it's just something you don't want to happen, right? And so this is how Colab allows you to safely store the API key, okay? So copy it into there. You can look at the key if you want, and then you just have to tick this green one here so that your notebook can now access the key, okay? So if there's any questions, just let me know. Otherwise, you need to do that to run the next set of exercises. And if you're sort of curious about how to set up the API key, just because it's such a common thing that you have to do, we just basically, it's like these 5 lines of code here. You just import a couple of stuff. And then you, in the environment, you get the OpenAPI key, right, from your secrets, and then you set it, as your key. And that's how OpenAI works. Okay, so I'll leave you to the second set of exercises down here. Okay, cool.
How long does the API key last for?
So just some other stuff to be aware of, right? Before we sort of move on to the next exercise. ChatGPT also allows this thing called RESTful API, which you may hear. If you're ever building a web application, so that is like a live website that you're chatting with ChatGPT, right? Like this is the thing you need to use, okay? And so how it works is it basically sends a HTTP request to the API, and then ChatGPT responds with another HTTP that sends back to you. So that's, for example, if you have a live website whereby you need to chat with ChatGPT, okay? So that's just if you ever intend to do that. Okay, so let's talk about Hugging Face. So Hugging Face is a very powerful suite of tools, right? And we actually won't be using Llama 3.2, even though I got you to get access last week. Part of it is because it's too big. I was trying it on the weekend and it just broke, right? And so we're going to get you to fine-tune something smaller. But how Llama 3.2 works is that they actually release both pre-trained and instruction-trained models. And so what that means is that if you use an instruction fine-tuned model, then you basically have the assistant structure, right? So you can ask it a question, then it provides an answer to you, right? So it's trained to do that. But interestingly, they also release the pre-trained models, meaning that all of the world's knowledge is in that one, but it's not trained to do anything, right? So if you ask it for a response, it sort of spits out like Amazon reviews, right? And so you can actually train Llama to do something else, right? Which is really interesting if you think about it. It doesn't have to be Q&A structured, right? And so the sky's the limit in terms of what you want to do. And so what this really is just a model that has all of the world's knowledge in it. That's it, right? So what you do with that is up to you. And so you can, like I said here, you can fine tune to the task that you want, right? And the sizes for Llama, they release all sorts of different sizes, right? So they have like massive models, like 90 billion for vision models. They also have really small models, like 1 billion, okay? So that's a small model. Okay, and so this sort of goes a little bit to how to think about transformers or large language models in general, right? And so if we take a look at the sort of steps of training a model, there's 3 main steps. One is pre-training, so that's unsupervised or self-supervised learning so that the model can learn about the world. And then you fine-tune, which is you have supervised learning to orient its behavior, right? So for example, it could be a Q&A model. And then alignment, which is for human preferences, right? And so those are the 3 steps. And so when you're thinking about AI, you have to think, okay, which of these steps do I actually need and which of these steps do I not need, okay? So for example, you have the world model, you can orient the model to do something else completely different, right? So it could be maybe you could build an AI that's really useful for some specific clinical task, right? And so it doesn't really learn to answer Q&A, but it does something else. So if, for example, you want to build like an AI that's, looking at all the patients and seeing if there's a patient that needs a Met call or something, you'd need to start with something like this and then train it to see, anomalies or Met calls or whatever, right? So that's your starting point. So you wouldn't start with the Q&A. If you, for example, want, an AI that answers clinical questions, then you would start with the fine-tuned one, right? Because you need that Q&A capability, and then you want it to improve on the medical Q&A, right? So you see, so different starting points, right? So the questions that I always ask when I'm looking at these sort of set of steps and where I should be starting is, in pre-training, what data do I need to feed to the AI? How to mask, right? So remember we have 2 sort of methods of masking. One is masked language modeling and one is causal language modeling. So those are the 2 dominant ones. I don't know if there'll be other masking methods in future, but you have to think, am I supposed to be using causal language modeling or masked language modeling? The second step is fine tuning. So this is what behavior do I want, right? Do I want it to be a Q&A assistant model? Do I want it to do something else, right? So you have to think about that. And what data do I need it to train it with, right? So obviously with Q&A, I provided hundreds of thousands of questions and answers, which are written by humans. But if, for example, I wanted to generate an image, like I wouldn't be using that data as the training data, right? So another important question. The third is alignment. So what are the human preferences and how do I actually train it? Okay, so that's sort of another step forward on top of that, which is how do we improve this? Now, sometimes, particularly for models which aren't Q&A, you sometimes actually miss this alignment step. Okay, so it is optional technically, right? Because you're going to have a model that just answers well and there's no real definition of human preferences for that task, right? And so you might skip alignment. So let's go through some examples. So maybe just hear from the crowd here. So ChatGPT, right? What data have they trained on? Does anyone know? Everything, exactly, everything. All the data on the internet, right? How did they mask it? Causal language modeling, because it's a GPT structure, right? All right, so that's pre-training. Fine-tuning, what behavior? Q&A, right? They just decided that an assistant model was the most useful, so question and answer. What data? Hundreds of thousands of Q&As. Alignment, what human preferences? So this is actually a really complex question, if you think about it, right? Like if you have an assistant that can answer everything, how do you align with human preferences, right? And so what they do is just reinforcement learning from human feedback or direct preference optimization. Okay, so say we have a completely different task now. Okay, so we cannot rely on ChatGPT. So now we have time series data, right? That is, say you have medical record data from the past and you want to predict the future of the patient, okay? So what would pre-training look like? So what data would you use in this case?
The medical data of the patient, right?
Yes, medical record data, okay? So if you want to predict the future, then you have to rely on past medical record data, right? Now, how should you mask this? Is this more of a masked language modeling or causal language modeling? Why?
Well, because you're predicting the next, like, what's going to happen next in the sequence of time.
Yes, exactly. So there's an inherent order if you're trying to predict from the past the future of the patient, right? So there's an inherent order, so time is a variable there. So you need to use causal language modeling, okay? All right, fine tuning. What sort of behavior would you want in this system? So is it a Q&A type thing or is it something else? You could, might not be as useful, right? Like what sort of stuff would you ask? Like is this patient gonna die or something?
Will this spit out warning?
Sorry? Yeah, so it could be, for example, like given these vitals for like 24 hours, is the patient likely to have some sort of event occurring, right? It could be maybe it's an event token, right? What kind of event? Could be, you know, hypertension or whatever, right? So that could be another way to do it, right? But you see how it's a lot more flexible now. There's no pre-written rules, right? It could be a completely different strategy, which is, let me see what's another strategy. Could be that it just highlights when a staff needs to come in. It could highlight the stuff that the staff needs to look at, right? So it's like, you see how you're defining the behavior of this, right? And the data that you need is hundreds of thousands of examples of this, right? And so you also have to think, well, what data do we have available, right? Like, do we have this stuff available in the record, like in the medical record already? Or is it stuff that we have to create ourselves now, right? And so you see how it quickly becomes practical in terms of like, well, we have this data available, and so therefore we can structure the model to do this instead, right? Right, what about alignment? How would you do alignment?
You do like human feedback from like through like conditions, and you do reinforcement learning.
Yeah, so that's an idea. So it could be that, hey, like this alarm you gave me, look, it wasn't that useful, right? And so you tell the model it wasn't useful, and then it learns from that, right? Other feedback, maybe the way that it delivered that information wasn't useful, like it missed important information, right? And so you have to let the model know that it's missed important information, right? Or it gave you very useful, very useless information, right? Like that was really not useful for that case, right? And so yeah, you can provide feedback like that. Yeah. So as you can see, like even just switching to a simple task that we can imagine in the hospital, you have to really think about how you're structuring the AI, right? Conceptually. Okay, let's move on to the next example. So clinical workflow. So say we wanted to do a clinical workflow, right? Like just history, exam, investigations, just the usual stuff. What data would you need for pre-training? Any ideas?
Like transcripts of like people taking clinical history exams.
Yeah, like actual like medical record notes, sure. You would probably want to connect it to actual medical knowledge, right? Like in terms of like, you know, what diseases are, like up to date or whatever. You know, like actual medical knowledge, right? That would be useful, right? What else? Maybe examination notes. I don't know, right? Like yeah. So it's just you have to think about what kind of data you have access to, what kind of data you can use, right? How would you mask this? Would this be causal or masked language modeling?
What's the output that we hope to get from this, like the thing that we are trying to do?
Yeah, that's a great question. So what is the actual output, right? So an example could be like, you know, like a patient comes in and then this AI just takes a history for them and then suggests examinations, which I guess someone would have to do, and then suggests investigations and then suggests diagnosis, right?
Maybe causal.
Sorry?
Maybe causal.
Causal? Yeah, because there's a time variable, right? Yeah. Does that make sense? So this is also causal language modeling because time, there's a time, you know, like there's a time variable when you're doing history. You do history first and then you do examination and then you do it. Obviously in real life, like it's not really, you're following that strictly to a T, right? But there is a causal, I guess there's like a time variable in terms of consideration of data, right? Like something will happen and then you have to do something else and then something will happen. And so because time is an inherent variable there, that sort of causal language modeling is key, right? Okay, fine tuning. What behavior would you want out of this? Any ideas?
Maybe like giving instructions.
Like suggestions for next steps.
Yeah, suggestions for next steps. So it could be something like that, right? You wouldn't want to fine tune it in such a way that it's rigidly like history exam, blah, blah, right? It could be that new information comes in, right? And then it has to be able to act on that information and suggest next steps, right? So maybe it is very much like this is the past, this is what's happened so far. What is the next step at this point in time, right now, right? And so it's almost a model that's constantly updating as to its current state and then thinks ahead as to what the next step is, okay? Alignment, human preferences. So again, thinking about how humans want to actually see the data that's happening, maybe transparency in the decisions it's making, right? So it explains like why it thinks that this should be the next step, right? Whatever that next step may be, right? Potentially even considering like what information, or presenting to the human what information it's considered in its decision, right? So that's sort of the stuff that you need to think about for human preferences. Okay, multitask agents. I think this is the last one. Yeah, multitask agents. So say you had basically, you know, like a Jarvis type thing from Iron Man, right? What data do you need to train that? What does everything mean?
Plus like personal data.
Personal data. Yeah, okay, yeah, sure. But thinking about, like, for example, it's able to do like a complex task, right? So you ask it to do something and it figures out step by step. The data itself needs to provide feedback about sort of step by step, right? And so, you know, like for example, if you want Jarvis to be able to do something physical, right? Then you need to provide it capabilities of seeing stuff, like image recognition capabilities as well, right? You need to provide it capabilities to actually, for example, control something or physically hold up stuff, right? So see how, for example, if you're building like a physical robot, right? Like, and maybe Jarvis doesn't have physical abilities, but if it does, right? Then it needs to learn like how to grip stuff, right? Or actually recognize a banana, right? Like if you're like, hey, give me a banana, right? It needs to actually see a banana, pick it up, and give it to you, right? So the data is not just all the stuff on the internet, but it's also like physical reality stuff as well, particularly if you need an agent that interacts in the physical world, okay? And so you sort of have to expand in terms of what you need. It's not just the internet. That's great for like knowledge-based stuff, but it's not great for physical world stuff. How to mask. So is this causal or masked language modeling? Yeah, I don't know. So actually, I don't know what the answer is for this, right? And I think it's an active field of research as to what type of modeling it is. It's not even language modeling at that point, right? It's almost like action modeling or something, right? Don't know. Okay, fine tuning. What behavior? So I guess at that point it's a bit of an assistant, but also can do stuff for you, right? So it's not just Q&A, but it's like a Q&A that can also go off and do lots of cool stuff for you. I don't know. Alignment, human preferences. Good question. I don't know what the answer is to this one. And I think it's a big question as well, which is, can we actually control the behavior of something like Jarvis, right? By just talking to it or something? Or is it some sort of setting that we need to do on the back end? I don't know, right? So actually I put this slide up just more so that you can understand that we don't have all the answers. Yeah.
The way it does action, is that by code?
Action. So yeah, that's a great question. There are two main ways, right? Usually one is through APIs, and then the other is through user interface. Right? So often, as in digital actions. Physical actions, usually it's attached to a robot arm and then it does something, yeah. Okay, so let's talk a little bit more about fine-tuning. So recall that we used to fine-tune for transfer learning by freezing earlier layers, right? If you remember from the neural network times, right? Now, fortunately, we have more efficient methods now, and you actually get to experiment with some of them in the next collab. So the predominant method right now for fine-tuning is something called parameter efficient fine-tuning, or PEFT, right? And part of the reason why is that with transformer or large language model architectures, right, they're so big that we cannot fine-tune the whole lot, right? We cannot even freeze some layers, even up to the final layer, and then fine-tune it, right? And almost that doesn't have an impact either. And so someone figured out mathematically that what you can actually do is figure out the ranks or the dimensions where the parameters happen to have the most effect, okay, for fine-tuning. Okay, so basically they just compress a giant, 3D cloud into something 2D, right? Obviously, like it's more like 100 dimensions or thousands of dimensions into very critical dimensions. And then you fine-tune along those dimensions, right? And that allows you to fine-tune models very efficiently, okay? And so with low rank adaptation, or LoRa, which is the predominant method right now for fine-tuning, it freezes most model weights and then it injects new weights into each layer. and then it reduces the fine-tuned weights that you need to change by around 10,000, okay? Which means that is a huge reduction in how much you actually need to do, what you actually need to do. And so that actually allows you to fine-tune even 7 billion models on Colab, right? It takes some time, right? So I tried it with the 1B, but it takes too long. But you can actually run it on Colab because it's memory efficient, okay? Performs much better than standard fine-tuning. But just one thing to note, if you ever use LoRa and you need to train your own model, right? For some reason, it does require a lower learning rate, okay? So it requires 3E minus 5. Now, QLoRa is another method called, it's quantized LoRa. Basically, it adds something called quantization, and quantization basically just means that when you have these weights, usually they're a very big decimal point number. Quantization means you just basically reduce the precision of those weights, okay? And you can actually bring that to the extreme. There's something called 2-bit quantization, meaning that you force it so that the weights can only be zeros or ones. Okay, sort of a really interesting idea. Again, a research field. We don't know too much about what happens. Obviously, just thinking about neural networks, it does decrease expressiveness, right? Because instead of a weight being like 0.01, it can only be 0 or 1 now, right? QLoRa also uses GPU tricks to reduce memory. It's slightly less powerful than LoRa, so you only use it when you have very limited memory, okay? So the sort of meta right now is, you use LoRa as a default. If you, for example, have very limited memory, then you stick with QLoRa, okay? Now with LoRa itself, it doesn't seem to work that well with some alignment techniques. So this is actually an area of active research right now as to why on earth this doesn't seem to work well with this, right? And we'll talk about what this means later. But yeah, like there's just, we don't know why. So that's PEFT. Okay, so Hugging Face, like I said before, Hugging Face, really popular. I think people also find this really cute. There are lots of useful libraries that are worthwhile knowing about. So Datasets is a library that has all the datasets, right? So everyone sort of uploads stuff on there. Data Trove is used for cleaning up data, so filtering data, removing duplicates, that sort of thing. It's called dedup. Tokenizers, you can use all sorts of tokenizers. So we played around with ChatGPT's tokenizers, but if you actually try and change the tokenizer you are using, the values that you get is actually completely different, right? So tokenizers play a huge role in how ChatGPT does. You can do things like evaluate how well a model does on certain leaderboards, and we'll talk about the different leaderboards. Nanotron is super fast pre-training. If you want to do AI demos, so for example, startup or project, then Gradio or Chat UI are really great packages to be aware of. And then PEFT allows you to fine tune. Okay, now when you take a look at different models as well, like for example, Llama or whatever, usually most models have something called a model card, right? And so model cards provide you a summary of all the useful information you need to know for different models, okay? And so these unfortunately aren't standardized, but it might include stuff like, what the architecture is, what's the input and output it expects, right? So it could be like a question and an answer, what the license is, what the intended uses are. Most of them will say you can't use it for medical use, right? You can't be using it formally for medical use. Training details, how well it does in benchmarks, that sort of stuff. So if you see a model card, like it's always worthwhile just quickly scanning through it and seeing if there's anything useful for your use case. All right, now we've talked about, Llama, Meta, and ChatGPT, but there's also other large language models as well. You might have seen Claude, as we've discussed. Perplexity is one that's search-based, okay? So it's like trying to replace Google, actually. So it's an AI model that's optimized purely for searching on the web, okay? So Perplexity, you can check it out. We'll talk about Mistral. It's a different type of architecture by a French company. It's also the leading EU company as well in AI. And then Gemini is Google's models, okay? So there's lots of different models around. Okay, so back to the collab. I'm just going to end there. So hopefully you now have a feel for sort of ChatGPT, like different models, that sort of stuff. Now a big question that we have is how we actually evaluate large language models, right? Because, being human, we have to say that our large language model is the best, right? And so how do we actually do so? And so evaluation is still very much an active field of research, right? And there's lots of questions, and actually I'm sort of curious to hear if anyone can think of a better evaluation tool, particularly for medicine, right? Because right now, what we use, and you'll see, they're all like MCQs. They're all like university level MCQs, right? Which is basically the stuff you do for exams, which is not that reflective of clinical practice, right? Like it's yes, it captures something, but it's not like really being a doctor, I think, right? And yeah, and I mean, there's obviously a big focus on immediate tools, like tools which are like, can this answer the question well right now? But it doesn't have like long-term planning or anything like that, right? There was sort of a frenzy during May to July 2023 where everyone established benchmarks, and then we've continued to use those benchmarks to this day, right? Those still remain the dominant benchmarks, right? So we haven't really had new benchmarks come up actually since that period. And so yeah, so again, the field is sort of looking inwards and being like, can we actually improve how we're evaluating these large language models, right? So let's go through, so there are actually 4 main evaluation tools that people use more generally, right? Not specifically for medicine, but actually just in general. And so the first is Chatbot Arena, and this is the one that most people use, right? So it defines corporate strategy, and everyone relies on this, right? Like every company you're aware of is always looking at Chatbot Arena. And how it works is it's entirely community sourced, so it's actually a community of people who just like talk to different AI models, right? And they decide which one is the best, okay? And how it works is that it's a blind multi-turn chat. So multi-turn just means that you talk to the model multiple times. Okay, so single turn means that you talk to it once and then you get a response and that's it. That's called a single turn. Multi-turn just means that you talk to it multiple times. You blind chat with 2 large language models, so you actually don't know which model is which. So it just says model A and model B. So it could be that that's like Llama and that's ChatGPT or whatever, you don't know, so it's blinded. And then you just select the best one. And then they do that at scale, right, in order to create an ELO score. So sort of similar to chess, right? Like ELO score, right? Or gaming. Now the sort of downsides of Chatbot Arena is it only focuses on the top models. Okay, so like ChatGPT, Llama, like just the big names, right? They don't really focus on models that you or I might create, right? Unless you have a big company. Obviously, you don't know the distribution of what people are asking, right? Because they're just chatting to a ChatGPT. They could be asking about anything, right? They could be asking about their taxes, whatever. It's just whatever, right? And so obviously you look at this and you don't know if it's medical related. You have no idea, right? Because they don't store what people are asking, so they can't analyze it, right? It's just merely you choosing. So in a general sense, it's what's best, but you don't know what people are really asking, okay? You also don't know what kind of users there are. I don't know, maybe it's a bunch of people from Europe or something, I don't know, or from the US. You don't know where these people are at all. So you don't know the user distribution or the prompt distribution. It's the most reliable thing we have right now, and you'll see why. You'll see the other free metrics that most people use as well. And I still think this is the best. It is also quite slow. So new models will come, and it takes at least a few months for it to percolate upwards, right? Because it's an ELO score. It's sort of like a chess player comes. It takes some time for them to climb up the ranks, right? So it's the same with models. And this is, as of last 2 nights ago, this is what the Chatbot Arena actually says is the best. And it's sort of interesting to see, right? So, Gemini seems to be up now. I don't know, right? Like just a week ago it was ChatGPT. Gemini seems to be the best, and then ChatGPT, and then O1 is like 4th and 5th. And then, so you can see that Grok, which is Elon Musk's model, is 7th. So that's just sort of what's there. And then you have the organization here. There's the 95% confidence interval. So you can see sort of if, the model's sort of in the confidence interval anyway. So there's like uncertainty around that. But what's interesting as well is that most of the models are proprietary, right? So 9 out of 10 top models are all proprietary. So is that great? A lot of them are dominated right now by OpenAI and Google. And so that just sort of reflects how much money you need to be at the frontiers, at the very best, right? But again, like these scores here, like what does that mean? Like you look at the score and it's like, you don't know what people are asking, what people are choosing. Has Google just set a bunch of people to click Google? I don't know, right? Like, I don't know, yeah. Okay, so that's the first metric, right? So you can always look that up at any time. If you want to be like, this is the best model we have right now, just search Chatbot Arena, and then you'll get the list, and then you can impress whoever, right? With being like, this is the top one right now. Okay, second tool is Alpaca Eval, okay? So how this works is slightly different. So again, just think about the methodology, right? Like how would you do this better is a really big question right now. So in this one, you ask the strongest large language model that currently exists on the market, right? Usually that's GPT-4, to judge 2 singletons, right? One from the candidate and one from humans. Okay, so I'm just trying to think what that means again. 2 singletons, 1 from the candidate, 1 from humans. Actually not sure, I can't remember when I wrote that what that means. But essentially the essence of this is that you have a large language model that is particularly strong, and then you ask it, presumably actually to judge from 2 different large language models, a single term, right? So that is a single question and a single answer, and then you see which one is best, okay? Now the concepts behind this one and what's sort of interesting about this one is it was the first evaluation method to use what's called LLM as a judge, which is using AI to judge itself, right? So that's just another concept to be aware of, right? Now the sort of pros of this is that it's completely automated, right? Smaller models are somewhat present, but sometimes when you use the AI as a judge, the AI actually doesn't even know what the best answer is, right? Because the task, for example, might exceed the ability of the AI itself, right? And so using AI as a judge, it's great from a, I guess like a financial perspective, right? Because it's all automated, but at the same time, sometimes the AI itself can't do the task, right? Therefore, it spits out like some nonsensical answer as to which one is best. Does that make sense? Now, unclear a little bit what better actually means, because you've used AIs, you're just sort of trusting the AI, right? So you don't know what the AI is judging as best, right? When you give it 2 responses from 2 different large language models, okay? So that's Alpaca eval. This one is also quite expensive, so it's $5 per model evaluation. So that would be considered quite expensive. Okay, multi-turn bench, so MT bench. This is when you ask a strong large language model, so usually they use GPT-4 or Claude, to rate a 2-turn response from 0 to 10 across 7 categories, okay? So they literally give a score being like, this is, I believe this is a 10, this is 9 out of 10, this is 8 out of 10, right? And they give that score for different large language models. Now the problem with this is that scoring is saturated at the top. So at the top here, there's just like everyone sort of bunch up at the top, right? And so the metric itself has been saturated, right? That is like, you know, there's just no further higher to go, right? So we don't know what higher even means at that point, right? The sort of pro of this one is that it's quite cheap at 50 cents per evaluation. Open LLM leaderboard. So this is another one that's also quite popular, and the reason why it's popular is it allows you to test anyone's model. So it could be your own model or whatever model. So you have some of the best small models on Hugging Face, and basically it just tests against different benchmarks. Okay, and we'll talk through what these different benchmarks are. But this is a useful tool for discovering new models. So models that aren't in the mainstream or people don't really know about, right? Sort of great to use for that. Okay, so let's talk about benchmarks. So there are a couple of common benchmarks that you'll see around. So the first is ARC, which tests scientific reasoning ability. So this is an example of a question from ARC. So you see it looks a little bit like a science MCQ, right? Like a general science MCQ. Okay, Hella Swag is another common one. This tests common sense. So I'll just zoom in here. So it's like, you know, how to catch dragonflies. So, you know, like this is the information you need to catch a dragonfly. Like which of these options is best? Okay, so does the model understand common sense things, right? Like how do you actually catch a dragonfly? And I'm not sure I can even answer this, right? But that's what it tests. Okay, another one is MMLU. So this is another really common one. This is basically high school / undergraduate level MCQs for different subjects. Okay, so it's like physics, maths, biology, anatomy, physiology, whatever, right? And so there's also an MMLU medicine, right? And you might actually see that around quite a lot, which tests large language models on medical specific questions, right? But if you take a look at the questions, they're not that hard, right? Like they're actually not that hard. They're almost a little bit like high school level / early undergraduate level. So they're not that hard, right? It's probably stuff that you could do now. Yeah, so that's MMLU. Truthful QA. So this is whether the GPT or large language model can answer true or false to funny-ish questions, right? So it's like, can coughing effectively stop a heart attack? Right? Is that true or false, right? What happens if you crack your knuckles a lot, right? So it's just asking like sort of stuff where, you know, the large language model has to decide whether that's true or false, okay? Big bench. So this is a diverse group of tasks. So they actually try to get diversity in this benchmark. And it's all sort of questions like, you know, if you follow these instructions, do you return to the starting point, right? So it's like turn left, turn right, take 5 steps, take 4 steps, turn around, take 9 steps. Do you end up at the starting point, right? So you see how it's a little bit like navigation, right? Sort of questions. And then this one is like sort the following words alphabetically, right? Like can you just sort it out? So it's like all sorts of like, how to think questions. So that's Big Bench. All right, medical benchmarks. So it was one of my sort of like pet peeves, but we actually have very few medical benchmarks, and all of them are medical school MCQs, right? So MedQA, Med MCQA, MMLU medicine, they're all medical MCQs. Now the one exception is MedHalt, which is a really interesting benchmark, and I'll go through what that actually means, but they cover medical hallucinations, right? So it's like, how do they actually assess that? Go through that in the next slide. But with the MCQs, like, you'll see Google release a new model called MedPalm, and it's like, we did better than everyone in the medical questions, right? And so we're therefore superior, and it's just a bunch of MCQs, right? And these MCQs are quite easy, right? Like, it's just regurgitation of knowledge a little bit. It's not really clinical knowledge. And so still a huge opportunity, like if that's something you want to work on your project, also something that we really need in the field, right? Which is how do we evaluate like medical stuff for these large language models. Another sort of creative one I've seen is they use the New England Journal of Medicine case challenges, right? So they use much more challenging cases. And we'll talk about this, but the problem is that if you're training on the entirety of the internet, most models have seen those case challenges already, right? So it's like cheating, right? Because you've already seen the answer in the question, right? And so, so usually these days people use questions that they write themselves and never post on the internet, right? Because that way you can be sure that the model has never seen the question or the answer, right? Yeah.
So when we say that they're trained on the entirety of the internet, have they access to all of the journals that are behind the paywall, that means? Or
Yeah.
on the ones that are all behind?
It's a great question. I think they have, but I don't know. Yeah. Okay. So this is MedHalt. So MedHalt is the hallucination test, right? So when I was reading through this paper, I thought it was really interesting how they structured evaluation, right? And I think it's sort of a direction of how we should be thinking about evaluation. So the first test was the false confidence test. So you present a multiple choice question and a randomly selected answer. So that is, you provide like just an MCQ, you randomly select one of them, right? Like just say B is correct, right? And you ask it why it is or isn't correct. Does that make sense? And you have the answer, which is really it's actually C, or really it's actually B, right? And then you can automatically verify to see if it's correct or not, right? So that's a false confidence test. None of the above tests, so you present the MCQ, so they just use the MCQs from the other benchmarks, right? You replace the correct answer with none of the above. And then you see if you can get none of the above, right? Very interesting. Fake question tests. You present a nonsensical question and see whether the model can actually tell you it's nonsensical, okay? Then the fourth one, this is PubMed related, but they would provide an abstract and ask ChatGPT to generate a link, okay? To see if the link's real. PMID to title, title link, so you can basically test all those connections and see if it's hallucinating random stuff, okay? So that's MedHalt. It's very interesting. And surprisingly, ChatGPT did worse and then Llama did best. So I don't know. Now, part of the challenge of benchmarks in general is that many benchmarks are starting to get saturated, right? Like getting to a point where all the models can do quite well for the benchmark, right? And so, like a big question, and I don't have an answer, is, what does harder mean for medicine, right? Like, is it a harder case or something, or is it a research question, right? Like, what does harder actually mean, right? And this company here created a sort of fund, right, where you can submit your toughest questions for, it's marketing, but it's like humanities last exam, right? What are the hardest questions that AI cannot solve today, that if AI solves, it's like, it's super intelligent, right? And it's really interesting when you take a look at this. Unfortunately, it's the deadline's already passed. But, like questions should be difficult for non-experts, not easily answerable. And as a rule of thumb, if a randomly selected undergraduate can understand what is being asked, it is likely too easy, right? Yeah.
What is it unsolved? Can you do unsolved problems, or is it only like solved
I
problems?
think it has to be solved. It can't be like solve me,
Okay.
yeah, like the law of, yeah.
Yeah.
Okay. Yeah.
So if you wanted to like compare models, you would have to somehow like distribute material without putting in
You see the challenge, right? Yeah. It could be a blind like it could be a blind evaluation where I don't know, you'd have to work with Hugging Face or whatever to be like that cannot be on, right? But when you're evaluating it, the model can see what you're providing. Right? Yeah.
Surely it would be good to like test disease, like to like make up diseases essentially, and then test the reasoning skills, like how this disease would affect the patient's physiology. Because otherwise, I feel like it can just regurgitate whatever's on the internet anyway. So
Yeah.
it's like there's no reasoning skills that are actually being demonstrated. Right?
Yeah, yeah. You could, yeah. That would be an interesting one. Yeah. Other thoughts? Okay. Data contamination, just like we said before, sometimes the model's already seen the data. You're asking it, right? I mean, all the MCQs that we have there, it's all public knowledge, right? And so ChatGPT's already seen it, right? Like Claude's already seen it. So it's a bit funny when you're trying to test it on it because it's already seen it and learned it, right? So the best practice is to test for info after the release date. So you know how ChatGPT, it has release date, it's like May 13th or whatever. You only want to test for stuff that's been released after May 15th, 13th or whatever if you can, right? But sometimes it's just not feasible. Sometimes it's just like you can't do that, right? Okay, now a quick note about fairness, right? Fairness is also another really challenging metric, right? In the CS field, there are 3 primary fairness definitions. Now, I actually don't fully agree that these 3 are the main ones, but they have emerged as the main ones. And so you might see them floating around. Parity basically means that positive prediction, so that is someone has a disease, right? Like probability of positive prediction is independent to the demographic. So for example, whether it's gender or race or whatever. Calibration indicates that accuracy is independent of demographic. Equality of odds indicates that positive outcome is independent of demographic. And there's sort of been some interesting theories stating that it actually isn't possible to optimize for all 3. So that is, when you give up one, you optimize one, you actually give up something else, right? And so fairness is another whole set of research, right? Which is like, how do we actually improve this, right? And we can't, model fairness, there is no single definition for fairness, right? So, and when you try and optimize one type of fairness, you actually lose on other types of fairness. Okay, so fairness is a lot more challenging than you might expect, right? And it's a bit of a pet peeve again, but it's like, when someone says the model needs to be fairer, it's like, what on earth does that actually mean, right? And if you try and make it fair in one dimension, it's less fair in another dimension. Okay, so fairness is also quite complex. Okay, how to train large language models. So if you're ever dealing with large language models itself, there are 3 things you need to consider. The first being the model, the second being compute, and then the third being data, right? And unfortunately, a lot of companies these days, they don't really publish much, right? And so we've had to sort of figure it out as a field together. So let's talk about models, right? So hopefully this is, again, revision for you. So what is the inherent task and training strategy? If there is some sort of time component, right? So there is like, a past and a future or whatever, then causal language modeling is what you need, okay? That's a GPT architecture. If there is no time inherent, then you should be considering masked language model and a BERT, okay? So that's just dependent on your task. In terms of starting models, you can consider, if you really want to start from scratch, like PyTorch, right? Which has the encoder or decoder architectures available for you. You can use Llama 3.2 or you can use any Hugging Face model as well, okay? Just depending on the license. Now you might also see this around. This is called an ablation model. So ablation models are small models trained on very small data subsets. So they're like ultra tiny models based on ultra tiny amounts of data, right? And people actually use them quite extensively in order to figure out which direction they should be going in. Okay, so it could be like you want to try, I don't know, like X-ray data, you can try that. Like you do a super small model on small data subset, right? Or you want to, try like this direction, like a different hyperparameter, right? Then you do another model, right? So people often use what's called an ablation model in training. And yeah, essentially it allows you to evaluate high signal benchmarks, right? And sort of get in the right direction. And it's quite common to have around 50 to 200 ablations. All right, common licenses. So you might actually see this around. Depending on the license, they actually might allow you to do different things, right? So MIT is one of the most common ones. It allows commercial use, modification, basically do everything, except you need to have the license preserved, right? So that is if, for example, you create something from something with an MIT license, you need to still have an MIT license yourself. Okay, so that's the MIT license. Apache 2.0 is similar to MIT, but you need to include a copy of the license or notice file, and you need to state any significant changes. GNU free requires any derivative works to be also open source. And then Llama is that funny one I told you where if you create something, you need to call the product Llama, okay? And if you run a company with more than 700, actually million monthly active users, then you're not allowed to use Llama. Okay, but I hope none of you have companies like that. All right, in terms of compute, so Monash, we have actually a free cluster of compute, right? It's called Massive. Because it's free, it's always used though. So you can try to use it, but it is free compute. We'll be giving you Google Cloud credits for your projects, right? So if you decide to do something where you want to compute a bunch of stuff, then you can use Google Cloud. It's obviously not unlimited, but it's something to kickstart you. You can use AWS, so that's Amazon Web Services. That's another way to access computers, right? Like computers to actually process stuff. And then if you're wealthy, you can also use NVIDIA GPUs, okay? So that's also something else on the market. All right, now practical rules about how much compute you actually need, right? And so in the field, we have a set of scaling laws, which tells you how many parameters your neural network or large language model needs to have per token that you want to train. Okay, so I'll just repeat that again. How many parameters your large language model needs to have per the amount of tokens that you have. Okay, so if you have less data to train, then you can rely on a smaller large language model to learn it. And if you have a lot more data to train, then you have to increase the size of your transformer. Okay, and those are called scaling laws, right? And so this provides sort of the optimal compute budget given the amount of data and tokens you have. And so in 2020 to 2022, we relied on the Kaplan laws, which stated that that you need to have 1.7 tokens per parameter, right? Where the parameters scale more rapidly. And so there's a bunch of math here. And so like GPT-3 relied on this, and they had 175 billion parameters on 300 billion tokens. Now, why I'm not sort of spending too much time on this is that in hindsight, they realized that they had a learning rate bug, okay? Which is absolutely crazy because this was a huge product, right? Where they actually spent probably like $1 billion in training, and then they realized they had a learning rate bug, okay? So we no longer use the Kaplan laws because of that bug. And now what we use instead is the chinchilla laws, right? And so this is 20 tokens per parameter, right? And so it's a much smaller model for the amount of tokens that you have, okay? So they had a 65 billion parameter model for 1.6 trillion tokens, so a huge amount of data that they're trained on, okay? And that was sort of the meta in 2022 to 2023. Right now, since Llama, I think 2 or 3, we now use something called chinchilla overtraining with Harm's law, whereby this is actually the perfect sort of answer. It's optimal in terms of the training that we have, but at inference, the model is quite large. And so what the sort of rule is that you decrease the size of the model at training, right? So that inference becomes cheaper, but you overtrain that small model. Does that make sense? So that's actually quite a complex point. So I'll say that again. What we're basically doing is we're overtraining a smaller model. Okay, so remember that overtraining was bad, right? But it actually is something that we do now. We use a smaller model because it's cheaper at inference when people are actually using it, right? Cheaper and faster to use. And so we have a smaller model, we overtrain it, right? And we basically keep overtraining as long as the loss keeps going down, okay? So that's the meta right now. Yeah.
So overtrain is in overfit? Or?
No, overtraining is in training beyond the optimal point based on the maths.
And is that optimal point when
Is that equivalent to overfitting? That's a good question. I think it's like you slightly overfit it, right? You slightly overfit it, but it's not massively overfit, right? Yeah.
What does it mean by inference is faster?
Inference is faster at, you know, when you're at runtime, when you're using the model, it's a smaller model, so it's just faster. Yeah. Yeah.
And also when you say loss going down, so the validation loss would start going up though, right?
Probably slightly, right? Ever so slightly. Because keep in mind these models are huge, right? And so the curves you probably get are huge as well. Right? Yeah. Okay, and so there's actually a website on Hugging Face you can go to. Although again, I don't expect you to be training these models, right? But this is sort of what people use. And so you can basically just put in the number of parameters, the number of tokens that you have, and then it provides you how much overtraining you should be doing. Okay? Again, just something to be aware of, right? It's unlikely you guys are going to be training your own models, but just something to be aware of in terms of this exists. Okay? These are some of the rules that people use. And so yeah, so for example, here's 7 billion parameter model. If you have 1 trillion tokens, then you essentially overtrain by about 14%, right? But then you reduce inference by about 45% every time you run it. Okay? So sort of huge benefits. All right, so we'll skip this one. Now other stuff as well. So in terms of, so that's the model, right? The second part was compute, and then the third is data, right? So let's talk about data. So with data, usually people get data from things like Hugging Face or Kaggle if it's open source, right? Or potentially GitHub sometimes for research papers. You can also get data from the literature. So sometimes the literature, they'll actually publish the data in some open source format, right? Or other sources. So, you know, if you have proprietary access to a hospital's data or whatever, that's also another great source of data. Now, in terms of best practices, you should always understand your data with manual inspection, right? So actually look at your data, right? And I've been getting you guys to do that in the collab. Look at the data, make sure that it's what you expect, right? And see if you can see any patterns in it, right? Always be looking manually. The second is that you always need to filter out bad data, right? And it's sort of funny because the meta about 2 years ago used to be that you just throw everything you can at the AI models, right? But they're realizing now that if you have bad data, right, it can also screw up the model as well, right? And models seem to train faster if you have good data. Duplicates are particularly bad because for some reason the model memorizes information, okay? So you don't want duplicates in your data. And then if you can, usually it's good practice to include metadata, right? Which is how data or files relate. Okay, so say for example, you're training, you know, this is an example for like coding, right? You know, in coding files, there are files that relate to each other in some way, right? So including how they relate to each other, even if it's in the same folder, is a lot of information that's very useful for the coder, right? For medical records, it could be, you know, like how it relates in terms of time, right? Like this could be like a year earlier for the patient or a year later for the patient, right? All that information is very, very critical to include, okay? And how you actually include it is you actually just include like these bracketed information there, right? Where it's like, that's the same folder, or that's the same record name, or that's the date and time of this occurrence, right? Because that information is stuff that humans find contextually very useful, right? And so therefore language models will also find very useful as well. Okay, so pre-processing. So with pre-processing, there's sort of a gold standard, right? I think it's 3 or 4 steps. The first is to remove your duplicates, right? And how we remove it is through a technique called min-hash and LSH. And you're going to see a code sample later, which does it for you. You don't need to write it yourself. It's actually quite straightforward. But what min-hash basically does is it creates a fingerprint for your token, okay? And it does so using fancy math. You don't have to sort of know it, right? It uses a bunch of hashing functions if you know what hashing is. And then after we create a fingerprint for the token, we then do something called locality sensitive hashing, which basically puts similar items together, okay? So it sort of puts it again almost semantically, right? So very similarly. And so that allows you to remove duplicates because similar items, once hashed with their fingerprint, will occur in similar buckets, and so you can get rid of the duplicates, okay? Again, fancy math, you don't need to know it, you just need to know that people use min-hash and LSH, and if you ever need to do it yourself, that's the gold standard, okay? Second is semantic or topic filtering, so you want to get rid of anything that's useless, right? So it could be, you know, medical record data, you don't want people's phone numbers there, right? You don't want like stuff that is actually not going to be useful for the task at hand, right? And so you need to get rid of stuff like that, right? If you're, for example, training an AI that knows how to code or something, you might need to get rid of like any information that's irrelevant to coding, right? And so that also massively helps. Step 3 is to remove personally identifying information, right? So it could be names, dates, you know, addresses, emails, just like stuff that could be personally identifying, right? So that's always good practice, and always you have to sort of remember this step, particularly for medical data. All right, and then the fourth is to decontaminate, which is to remove any benchmark data, right? So if you're training, for example, Llama, and you want to check if it can do well in, you know, Med MCQA, then you want to remove anything related to Med MCQA from your data, right? So decontamination. Okay, now that's sort of data, and a sort of big field that's coming up is synthetic data. And part of the reason why is that, like I said before, GPT-5 is slowing down. And part of the reason why is because we are running out of data, right? We're literally just running out of how much data we can provide these models. And so people are looking at synthetic data as a solution, right? Now, what does that mean, or what are the implications of that? So it is unfortunately the only way we can get out of our current data bottleneck, right? It might worsen biases, okay? So if you think about it, the biases that it sees, right, because it's sampling from the same distribution, those biases are going to worsen if you keep on creating synthetic data, right? But it does allow the model to see rare stuff more often, okay? So it seems to help regarding rare stuff. Now, what is the gold standard for creating synthetic data? Basically, you get a bunch of humans to write seeds, right? Like seeds that are rare. So that is like information that is rare to find on the internet, okay? And then you use AI to synthesize based on those seeds. Does that make sense? Okay, so it's a very unusual technique, but we discovered it sort of last year. You basically, so I'll just repeat it again. So you get humans to write sort of paragraphs or whatever you like about rare stuff that you cannot find on the internet, and then you get AI to generate it again and again. Does that make sense? So historically, there's been multiple methods that you should be aware of if you ever want to do anything in this field. The first is called Stanford Alpaca. So this was essentially a group that decided that you needed to have high quality seeds. And then another trick that they did was that they removed items that were generated with high cosine similarity to existing items. Okay? So that is the stuff that the AI generated was very similar to existing material. They would remove that. Okay? And so you're basically generating rarer stuff, if that makes sense, right? Because you're filtering out the common stuff. Okay, any questions on that? Okay, another thing to be aware of is Microsoft Phi. So they basically did an experiment where they were trying to generate, based on all the data that they had, textbook quality synthetic data. So synthetic data that you'd be proud or happy to put in a textbook. Okay, so that was, and it'd be worth sort of reading about that if you're interested. And then Cosmopedia is another method, which is synthetic internet data, right? So they created a huge corpus of internet data, right? So that is things like Facebook posts, Instagram posts, Reddit posts, all sorts of things, right? And so they wanted to create sort of something that looked like real human data on almost like another internet, right? Okay, and so this goes back to our question, which is, if we're generating this data here, right? So this is the data we already have and we're generating stuff. You always have to be asking what data are we missing, right? Because if you're generating synthetic data, you can never sort of sample, for example, from here, unless you have some sort of examples of it, right? Because the model doesn't even know this exists, okay? So that's sort of what you need to think about as you're creating synthetic data. Okay, it's just some other stuff before we move on to the next exercise. Hallucinations, right? We've all heard about it. It's basically when the model doesn't know what it doesn't know, okay? And so this is inherent in the sampling procedure, and there's all sorts of fixes that have been suggested. So for example, using a lower temperature reduces hallucinations, right? And so using a lower temperature is really critical for medical use cases. You can ask the model to provide confidence ratings, so providing how confident it is about something. Sometimes it can predict the hallucination prior to generation, so it actually has a realization that it's trying to hallucinate, right? So that's another sort of area of research. You can sometimes ask models to verify the facts before it spits out information, right? Retrieval augmented generation is another method we'll talk about tomorrow. And then output self-refinement is another technique. So all these are research directions on how to reduce hallucinations, right? Because they're sort of a serious issue right now with large language models. All right. And then just a couple of other useful resources, right? If you ever decide to sort of release your own model, things that you should be considering is PII removal, so removing any personal information. If someone sees that there is something of theirs personally in your model, then you should provide them the option to remove it, right? Another thing as well is opt-out available. So for example, if the New York Times sees that ChatGPT has copied their paper, right? Then they can actually request for that data to be removed, right? Now, can you remove it truly? I don't know, it's really difficult, but you can remove it in future versions of training. Does that make sense? So you can't remove it if it's already been trained into the model. Transparency index, so this is a index which tracks how transparent these models are, so how much information has been released about these models, okay? Again, just something to be useful if you're sort of interested in this field. And then artificial analysis, so this is also another really useful website if you want to do stuff, right? And this basically tells you the quality of different models, the speed of different models, as well as the price of different models, okay? So if you need to keep track of, you know, hey, I want to use it at this price point or whatever, you can keep track of it using this website, okay? All right, so that's actually it. Let's see, so at free. So as a sort of last exercise of the day, just get you to finish part 4, and then we'll head off afterwards. But this will run you through how we do data pre-processing, right? And you're welcome to use the code in future if you need to use it. And then it will also cover how to create synthetic data. Okay, so actually get you to do a bit of an exercise to create synthetic data.